Super. Great. So as with all the sessions, we have got this one ready to go. The chat is open, so please do post your questions in and enjoy the session, everyone.
Hello everyone, welcome to TypeScript 101, Increasing Productivity and Developer Experience. Let's reduce my camera and let's get to the next slide. Just one sec. Okay. Who am I? My name is Luciano Souza. Some people in Brazil know me as Primo Dev or simply Primo. It sounds like Cousin or Cousin Dev in English. I have started in tech career in 2014 as quality assurance, and I had the opportunity to work with control version analysis with Git, GitHub, and Subversion, specifically dedicated to this role. But in 2015, I became software developer. I'm setup addicted. I really love to build my own things, to grab the pieces and build my own PC. I love to build my own keyboards too. I have a lot of keyboards. Some people in Brazil know me just because there's different keyboards. And I guess this is all you need to know about me before we dive right in our topic. First disclaimer, I will disable my camera. I guess it will be more easy to not hide any important info in our slide or in our VS Code. We will code in the session. And my camera is not on the screen, but I'm still here, okay? Let's do it. Today we are going to talk a little bit about TypeScript, as the title suggests, and the main goal here is to clarify TypeScript usage and its benefits, okay? And the first thing that we need to talk is about requirements, because we need some environment or some stuff to be able to run our TypeScript or our JavaScript code. And basically you will need Node.js. Probably you already have this installed on your computer, but if not, I'm specifically running the version 20.11.0 at this time, but probably if you are using any kind of LTS version of Node, this will fit, okay? Talking about Node.js yet, maybe you are asking why Node? Why not use Dino to run TypeScript? Dino has been released with out-of-the-box support for TypeScript if you don't know, but the latest version of Node already supports TS2, and to be honest, the adoption of Dino is so slow that Node.js is already able to support all the basic stuff you need to run an entire TypeScript code. So there's no much sense to install a third-party stuff to run and make the same thing that Node already do, basically. After an environment to run our TS code, you will need an editor. I guess most of the recent editors or web developer IDE already supports TypeScript, but as I am using Visual Studio Code during my day-to-day work, for me it makes sense to keep using it, in my opinion, to keep this talking with the 2 feet in the ground in terms of what do you will do in real-world applications, or what kind of tool you will use in real-world applications, right? But if you prefer, you can use any web environment like GS Fiddle, for example, or TypeScript Playground, maybe. But feel free to choose your preferred toolchain if you want to code this example or just follow this instruction and try this before. This is your house. Before we just jump for the next slide, let me make a quote. Sometimes I think that to understand our future or our present time, we need to look behind. We need to look to the past and understand it better, And I'm saying it because if you want to understand the TypeScript today or in the future, you need to look behind and understand the JavaScript thing. If you don't know, JavaScript basically was born in 1995 through the brilliant work of Brendan Eich, and he was just trying to bring dynamic features and dynamic behaviors through the browsers at this time. After it, JavaScript have matured so much, and the responsibility to this standardization fell to the ECMAScript International Organization. Let's just call this ECMA because it's a huge name. And the basically work of ECMA on this was ensure consistency and compatibility across platforms. This ongoing standardization process resulted in regular releases serving users and developers with a stable and multi-use tool for web development. Thinking on it, TypeScript naturally has evolved as a superset of JavaScript. not as a new language or a new tool. Basically, I love to talk that TypeScript is JavaScript but with superpowers. Which superpowers? We have a lot of advanced features like static typing. Ultimately, has TypeScript is already so much mature too. The developers are basically enhancing the developer efficiency, experience, and the code reliability. Alright, and if you do not have sure about the TypeScript adoption or migration, let me enlighten some points for you. The first point is when you are using TypeScript, you are able to catch errors early. And what this means? I have worked on some applications with some technologies that basically you implement a bunch of code and compile or transpile it, execute and run all the user flow authentication, adding some data or filling some form. And when I hit some feature that I have implemented, I noticed that I forgot a letter, for example, or I made the wrong map or thing like this. This is awful, basically awful. If you had the chance to catch those errors in development time before you just redo the same flow a lot of times and waste your time doing it, you will be more productive. Basically, these 2 points walks aside because you are not doing the same job every time to ensure that your application is running or not, you know? And how you are not doing this, you have more time to focus on things that matter, on things that really makes the difference and help your application grow, you know? Well, and talking about community, you know that JavaScript had a huge community. And when we talk about JavaScript community, we are talking about TypeScript community too, because they are the same, you know? Remember, TypeScript is just JavaScript with superpowers. So we have a lot of JavaScript users that already uses TypeScript or had already used TypeScript sometime. And a lot of them will be able to help you and will be happy to help you in something. It's not about just about the help, but if you have a huge community, you have a lot of companies adopting it, you have a lot of tools being developed for it, and so on. And this is good. This keeps the language or the tool alive, you know. And last but not least, we have the gradual adoption, because some people think that if I decide to use TypeScript on my code base, I will not use JavaScript anymore. I need to delete all the JavaScript code of my application. And this is wrong because TypeScript accepts to run aside the JavaScript code. You do not need to delete all your application and start a new one from scratch to do the same thing in TypeScript. You can gradually just add incrementally code in TypeScript. You can decide in the future if you, for example, want to migrate everything or just the critical part, or just the backend, or just the front end. You know, you can decide. This is interesting. You do not have a kind of, you know, framework that will decide this need to be this way. You can decide. This is so good. All right, still talking about JavaScript and TypeScript. Let's take a look on this code. Here we have a function called update user details that receives a parameter called ln. And we are returning any kind of user data that is in some part of our code, and this ln parameter as a property, right? We don't know which type is this ln until we look on this line, because here we are seeing that update user details is receiving a string called oprimodev as an argument, basically. And second thing, we don't know what we have inside this user because we are not seeing this user. Generally, if this user data comes from a remote server or an API, you will know just after logging it on a console log or console warn, for example. This ln property already exists on the user or it's a new property? Are we adding a new property to our user object, or we are just updating it? We don't know. We do not have much info about it. And this is how our teammates are feeling now when they see our code. They need to keep wondering and supposing things. And to be honest, this looks like many questions for a smaller piece of code, no? Well, let's suppose that our user data has a property called last name, and that I want to update it by just replacing this existent with my new last name that comes from ln property. But after we checked our remote fetched user, we noticed that our user object, the last name is written differently. This is using camel case convention, which means that executing the updated use details function, this will create a new property instead of updating the last name, you know? Basically this, if you log this will return all this bunch of code more the ln property. Right, and in the first time that we run this code, we can just console log this remote user data and discover what we have on it. But by this way, every time this payload changes, the developer will need to console and manually check it. This makes sense if you have a user with 4 properties, for example, but does not make sense in a payload with hundreds of properties. It will be really, really hard to track. Another point is that if my backend or database is waiting specifically for this last name property, probably I will get some error. The issue is, if I push this typo for my production environment, it will break because JavaScript just validates this data when it runs. And depending on the size of code base, I will spend an expressive amount of time to find and fix this typo. It's in situations like this that TypeScript simply shines, because it will warn me in development time that something is wrong, preventing this small piece of code going to cause problem in our production environment, for example. Okay, maybe you are looking for this code and thinking, why he just don't use JSDocs, for example. If you haven't heard about JSDocs, let me quick explain you. JSDocs is a way that we have to documentate every single thing on our JavaScript code base. But basically, this will just documentate. This will not enforce anything, any behavior, or any type, for example. It will not narrow everything, basically. Let's take a look on it. It's better than just talk. As you can see, the code is a little bit bigger than the original code, but it's the same, basically. And here we have a kind of documentation that represents the user objects, and we have the type def, that is basically the type of this amount of data. And we have the properties. We have name and last name, that is a string. And we have an age called, a number called age. And here we have a set of strings called superpowers that is basically an array that can receive a lot of strings. So here we have a user object, a real user object, with our properties name, last name, age, and superpower. Okay, and if you look here, we have the same kind of documentation, but focuses on functions. So we have the param here, because this is a param, and we have the return, that what this function will return for me after everything will be executed. And this returns an updated user, as you can see. And the param ln, it's the last name to be updated and needs to be a string. But what happens if I place a number here? Nothing happens, because this is not narrowing what needs to happen. As you can see, we have a documentation here. This basically show the tooltip with all info here, but this is not complaining about the wrong thing. And there's another wrong thing here. If you check, we have last name written on a different pattern from the original object, as you can see. What this means that when you console log this data, you have all those properties and a new property called last underscore name with the ln value. So this is not the behavior that we want to do. For me, it's a kind of red flag, because I have afraid to just have more comments in my code than code. Then specifically, I will waste more time trying to explain what is happening here than just trying to make this code more readable and more simpler and more cleaner, To be honest, I do not have anything among people that use comments on code, but I prefer to not use it because, for example, Imagine this is a huge code base with hundred or thousand of files. How I'll keep this updated in every single file? There's no way to do it. I need to specific people to do just this update and just keep this doc, on the right way. So this is not a feasible thing for me, to be honest. I prefer TypeScript than JS docs because basically we are not narrowing or enforcing nothing. We are just creating documentation to when I pass the mouse here, I will see this tooltip or this pop-up with every single information that I need. But if I'm attentioned user, I will not read this and I will do the wrong thing without any kind of complaint in my editor, and will get this error only on my final product or in my final production build, for example. All right, before understanding the specific use case of TypeScript syntax and utilities, let's break down the supported types and resources, okay? The next slide. So before we just dive in on these types, I need to disclaim a new thing. In TypeScript, various constructs are referred to as types, and maybe this will sound a little bit redundant, but I'm saying it to illustrate to you that the definition of type will change according to the context, okay? So this basically will change. Here we have the primitive types on TypeScript. So probably if you are already a developer, you are familiar with these types, maybe with different names or things like this. Maybe more types, maybe less types. This is not the question. But basically we have numbers for numeric values, strings for text data, booleans for true or false. We have null and undefined for null and undefined values. And stay calm, I will explain a little bit more the difference between null, undefined, and any in TypeScript. So just stay calm. We have symbol here that we can use to represent unique identifiers in our code. And we have big int that basically represent large integers or large numbers, okay? This is the most basic types that we have in TypeScript. Generally, we are using these types to create a composite type, a set of types that will define, for example, a user object, a product card object, or a product card array, or things like this, okay? Let's see a code as an example. I guess it will be more easy to explain. Let me just comment it because this will conflict with my types file. Here we have a file. First of all, you are seeing that there's something wrong here because we have an error here. And to this error, we have, I guess, error lens. Yeah, error lens. This will help us to highlight errors. If there's no errors appearing on your VS Code, just add this extension. Cool. Types, so let's ignore this by now. Basically we have a basic declaration of type. We have a type, the name of the type, in this case is name, and a string that is the specifically type, okay? This is the basic structure of a type. Type, name, equal, that we are assigning a value to it, a string, right? Here we have a new type, but following the same structure. Sorry, we have the same type following a different structure. We have type age that will be a string, but this can be a number too. So basically age can be string or number. It means that I can just write age it's equal to 20, or I can write age is equal to 20. It's the same thing basically, okay? And here I will just be using this. The type name is a string, and I will just place name here. And why I'm doing this, putting this name here, just to show you that I can just group types to create composite types and interface, as I had said before. Why I'm not just placing a string here, because this value is a string. Just to show you that we can reuse this name type in every place that we want, basically, okay? We can put name here, we can put name here, but it's wrong, but we can use it here, and all those will be strings, different strings. All right, age is the same. As we know, age is receiving and accepting string or number, And we have the superpower that is an array of strings, or as we know, this basically this is structure. A, ability B, power C, and so on. Basically, this is the superpower string array. Okay, if you look down on this 12 line, we see that we have TypeScript and VS Code complaining something. The type object is missing the following properties from type user props. Well, as you can see, we have a constant here. It's a variable, but does not accept updating. It's a mutability case. And this type is user props. That means that we need to have these properties, these mandatory properties inside it. As you can see, for example, name, okay? And when I start to type, they already will complete this for me without the completion. Let's say Luciano, and just control space, I get last name. Let's say this is Souza. And we have age, it's 32, and we have superpowers, it's an array. Oh, and the interesting thing, if I just place a string here, it's not assignable because we are expecting an array of strings, not just a single string. So to fix it, let's put this array here, and now this is working. This is great. As you can see, there's nothing complaining more because we are using everything that we need and filling all this user. But let's say that superpower is an optional thing. I don't want to be obligated to send superpower in my user. I can just add a question mark here, and now superpower is not mandatory. This can be undefined. I just can remove it, and my code will not complain about the absence of superpowers. Great, no? All right, now we are aware of the existence of types. We know how to declare type. We know how to declare type that can receive different values. We know how to compose this type and create, for example, an object shaped like an object in JavaScript Word that will receive properties and values, okay? And how to apply it. And we know that if we do something wrong, this will complain for us that something is wrong. Let's put false here. It's better. Like this age is waiting for age that is string or number, and false is a boolean, and this is not assignable for the type age that we have here that represents the string or number. But I want to show you a new thing. I want to present you the interface. Basically, this is the probably most questioned thing about TypeScript. What is the difference between interface and type? And this is a common question, but this means that you have not understood the purpose of interface and the purpose of types, okay? And I will try to show it for you on this section. First of all, if you just look without think too much, we have this keyword called type, and this keyword interface here, and we have this equal sign. That means that we are assigning an object for this type. Think on it. Assigning an object for this type, which means that this type can receive everything, okay? But I need to assign it for this type. And interfaces are created as object-shaped types, so this will be always an object. And when we want to create an array, for example, or return an array, the good thing is to create a new type. For example, here we have an object that can be an interface called user props. As I want to create a new type with a set of users, I have created these users and placed these square brackets on the end of this property. So now the TypeScript knows that I'm expecting a set of users when I call this type. This will not happen in interfaces, but we have an array type here. I guess this is the most common way to do it, but you see that we have an object type here. Okay, let's dive into our other object types. So basically, we have a lot of object types. If you see, we have object literal types, interface types, tape alias types, clear types and array types, as I had said. I will not read the description of it because I want to show you the code. I guess it's more productive, okay? I have an example for each one of those. So let's start with object literal. As the name suggests, this is a literal object. I'm just creating a type and assigning an object for this type. How we had seen in types, we are assigning these properties for this type. Cool. This is an object literal. Interfaces, as I said, will be always an object, so I do not need to assign this object here because we are expecting always an object. So in this case, I have an interface called credit card with a lot of properties with different types. And here maybe you already have the answer that you are looking for. When you are trying to describe an object, you probably should use interface. And when you are trying to describe any other kind of data, you probably will try to use types, okay? The type alias type is basically a type that refers another thing. We have done it on this. We have this type alias called name, and we have used it on here because we know that we can just reuse it in different parts of our code. So this is the reason that type alias types exists, okay? We have a type Asia that receive a number, a type name that receive a string. This can be a number or a string or a boolean if you prefer, and so on, okay? This is the type alias types. So basically, as I have declared these types, I can use it. Let me find, I have person here. I can reuse it and create a new type as you had seen on this, because I'm just reusing this and this here. This is the type alias type. Cool. All right. Now we have these class types, and if you already worked with object-oriented programming, this will be not strange for you. Basically, I'm creating a class called person that receives a constructor, and this constructor have a lot of properties that have a property name and the property type, okay? And as you know, we can set if this will be public or private or protected or read-only and so on. Cool. And last but not least, we have array types. As I said, we can create arrays on object types, but as you can see, for example, we have the type amount. We have a number and an array bracket sign here. We have the type count. We have a number and the array around it. This two is the same thing, okay? This is the different two ways to do the same thing. You can say number, array, or array of numbers. It's the same. Okay, as you can see, we have T here. That means that the type that you pass here will be the value we expect. For example, I can just pass, let's try credit card here. So I can pass credit card here. And now count will expect an array of credit cards. Interesting, no? We still have more types to see. Let's check out the next. The function types. This is so easy to understand, but let's check the code is more easy to read. Function type. Let's increase this font size. All right. Well, as you can see, this basically defines the type of what you are using on a function. And we have a type called add function that can receive parameters. In this case, are receiving A and B, and both are numbers. And this arrow means that this is a common arrow, okay? It's an equal sign and greater than sign. In my font just have font ligatures enable and show this symbol. But basically this means that we are receiving a bunch of numbers and expecting that when I call this add function, this will return a number for us. So here we have the const add that receives the type, okay? We have the parameters, and now our operation is just a sum, and this is a automatic return. So basically this means it return x plus y. Okay, it's the same basically. This is return. This is what I expecting for my add function, a number. 3 plus 4 will be 7. This will be the output. Okay, cool. And if we want to test it, as you can see, string is not assignable for add type fn because string is not assignable for type number that we are expecting it. We can just add string here, and now all things is working, but this is wrong. So let's just add it here, and cool. This is the right way. Basically, this is the function types. All right, let's take a look into our next type. It's the union and intersection. Let's make a breakdown for it in our code. Let's just open this union and intersection. As you can see on the top of the file, we already have seen this union type. So basically, this means that age can receive a string or a number. Never buff, never boolean, never another kind of value, never undefined, just a string or number, okay? Basically, we can just say age is equal to 2 or age is equal to 2. This is complaining error because I'm not on an object or on kind of structure. Let's say let age that receives age can be 2, okay? This would be better. Okay, and if I update it, let age that receives the type age is equal to 2. Basically, age can receive string or number. Okay, this is pretty easy. Intersection type will use any other kind of type to join types and made a new type based on it. So the most basic way to intersect a type is creating a type and referring to another type on some of the properties. So I have a name and an age. The name is a string, but the age is the kind of type age that can receive a string, a number. Okay, this is a kind of intersection. But we have another way to do intersections that basically is adding this e-commercial sign. So as you can see, this is the person based on person type. And if I add this e-commercial here and type email, now I need to put an email property that's will be email@.com. Okay, anything email. This is basically an intersection type. I have aggregated the person, the age, and the email, and created a new type that will be available for this person, for example. Right? So cool. Well, let's talk about our next topic, that is literal types. Cool. This is so interesting because basically the name describes the type. It means that if I use this credit card holder type or this vehicle type, the value will be just those values. Credit card holder can just be MasterCard or Visa, for example. Vehicle type can be just bus, car, or boat. I cannot accept strings, numbers, arrays, anything. The next one will be any versus unknown. This is really interesting because any is a type that represents anything in JavaScript. It can be any value, any kind of primitive, okay? And unknown, it's a type safe counterpart to any. Basically, it means that you cannot, you should validate the data or the format before performing any kind of operation. It is because if you use any, you can perform any kind of operation in your variable. And this will not get errors if you cannot do this operation, you know? For example, trying to do uppercase on a number. This will not work, but you will not know that it's not working in development time, just in, you know, running time in production environment, things like this. So let's create an example, quick example here, because I guess we do not have. So let's create any.ts and let's create a lat const value that receives a null. Cool. And this null, it's equal to 42. It's a string, right? Well, if I just do value dot, I do not have any kind of methods like true, locale, and anything like this. So if I do a counter part of the type safe and just, if value it's equal to string, but it's not the right way. Let's just type of it's equal to string. So now I have value dot and all the methods that string should have, like for example, locale, uppercase, lowercase. Okay, this basically means that when you use a null, you need to validate this data before you use it. This is the question. All right, let's talk about tuples. This is interesting because tuples always will be representing a fixed number of elements with specific types. For example, I have coordinates and this coordinates receives always two numbers, latitude and longitude. This will be always the same properties. I cannot pass 3 different numbers, 4 different numbers, or 1 different numbers. It needs to be 2 numbers in this case, because when I define the time coordinates, I define that this type will receive an array with 2 numbers. Okay, basically this is the tuple, and here is kind of simply usage or simple application. We are using this as a coordinate type and passing some coordinates to it. Cool. Let's just open this file and talk a little bit about this interface situation. This is called extensibility. This is a property for our interfaces that you will use a lot. So let's understand it. Let's imagine this situation. We want to document how we create a car, and we say that all cars have doors and wheels, okay? And this doors is a number, and we have 2 or 4 or 5 doors, and this wheels is a number. We can have generally 4 wheels, but let's imagine that we have more or less wheels. Okay, cool. Let's imagine that I'm creating a new interface to represent the Marty McFly car, and I will just call it Marty McFly car bad because I have a best option to do it. So basically this car have the same properties. We have doors and we have wheels, but we are not using this. We had he write doors and wheels here. It's no good. Okay, but this Marty McFly card still has another properties. This use rocket fuel that is a boolean, and time travel enabled that is a boolean too. Cool. Cool? Not. It's not cool. This is the reason that this is named Marty McFly car bad, because we are not, don't repeat yourself stuff. We are repeating this kind of data and we don't need to do it. So let's check our good example. Let's just remove these spaces. So in the good example, as we can see, we have an interface called Marty McFly car that extends the car. We have the car with doors and wheels, and Marty McFly car extends this car. So they have the car properties, but they have two rocket fuel, usage, and time travel enabled boolean property. This is so good. And if you create const car, you just pass Marty McFly car here, and now as you can see, I can just add my doors, time travel enabled, use rocket fuel, and wheels. Cool. So next stop inside this interfaces is about declaration merging. For example, we cannot do this in TypeScript in types on TypeScript. We cannot just declare the type house that have the property address And after, if I want to add a city to this house, I just say type house again and say it will be string on a city. I cannot do it. But in interfaces, I can do it. I can declare an interface called laptop, for example, that have a brand and it is a string. And I can, in other part of my code, in other file, for example, extend this interface and add a new property called CPU that will be a string, okay? And as you can see, I can just refer to it, and the point of this referral, I will be referring for all these interfaces joined or grouped, and basically have brand and CPU. Maybe if you already work with TypeScript, you was waiting for any kind of special trick or magic thing, and to be honest, there's no magic. It's just a lot of work under the hood, and Node made in their job, basically. So we need to understand that TypeScript can bring superpowers to our code base, and static analysis is one of them. This means that you will discover bugs and issues in your code before running it on your application, or before running your production server, or making an upload, or basically in the exact time that you create each piece of code. And this is really interesting because, as I said, I have worked on some applications that you code, you compile or transpile, and do all the user flow and discover at the end that is missing some letter on the variable that you have created. This is awful. You have tools running your IDE or in your editor, probably on your remote server, on a transpiling process or a compiling process, and so on. Have a lot of tools to run in different stages, basically. This is the idea. And you need to be aware that there's a lot of things happening at the same time in your applications, okay? If you are using VS Code, probably you are using ESLint, TSLint, Prettier, or Editor Config, or let's say Errorlens. There's a lot of tools that you can install to help you to do it. You do not need to assert every single line with your eyes. You can just use your attention and your brain to, do more specific and important tasks, okay? And talking about remote server and static analysis, you have tools like SonarQube, for example, that you can run during your compiling process, your building process, or on a pipeline, or when you push a new code for your GitHub repo, for example. We have a lot of tools like SonarQube, okay? Some free tools, some paid tools, and I guess you need to, navigate between some of them to discover what is the best tool for you and what is the best tool for your needs, okay? So thank you so much, and feel free to reach me from my social networks on primo.dev, my portfolio and website. So before just close to the questions, in this repo you will find this resources file that I add some slides and some courses, free courses, and cheat sheets and language docs and things like this. Feel free to reach me and ask me if you have some questions, okay? Now, let's go for the questions time. Hello everyone, welcome to TypeScript.
Okay, super. Thank you very much for the session, Luciano. Let's just make sure we get the right screen up here.
Yeah, I'm here.
That's
You're
brilliant.
welcome.
Some great comments already. Just thanking you for the introduction, Lucinda. Also, Nils, who did one of the earlier sessions, saying, great introduction to TypeScript, awesome job. I must say, as a developer who deals with object-oriented languages most of the time that I am developing, TypeScript is lovely to see. The structures and everything that it brings in is just really, really powerful.
Awesome.
Okay, so quick question that's come here. I feel that TypeScript made my development process slow at the start. What do you recommend to speed it up?
Well,
Generally, on the beginning, there is no place to run, how we say in Brazil. You will be a little bit slower because there is a learning curve that you need to understand how the TypeScript works and things like this. So generally, the documentation and the cheat sheets will help you a lot on it, because it's a little bit hard to understand everything on the before just start coding, if you are already production running project. So basically it's an inevitably pain at the start, but you gain a lot of time in the future when you start working with TypeScript.
Yeah, I think it was Abraham Lincoln said, if I had the day to chop down the tree, I'd spend the first half of it sharpening the axe. And sometimes, the time up front pays down, along the road as well, which is pretty cool.
Yeah.
So also, do you feel that at any time people stop using JavaScript as it is, does it still make sense to dedicate time to JavaScript resources?
Well, we know that the TypeScript comes from JavaScript. So as the JavaScript evolves and grows, the TypeScript grows too, in terms of tooling, in terms of community, in terms of language maturity. So basically, you need to understand JavaScript, and probably you need to understand JavaScript if you are a new learner in TypeScript. So it's hard to say that you will not need JavaScript in the future. You probably will need to understand JavaScript before just dive right in the TS stuff.
Okay, another question here. Can you mix just normal JavaScript code into if you've got some JavaScript code you've already written, can you mix it in with a new TypeScript project that you're writing?
Sorry, maybe my headset is just cutting a little bit. Can you repeat the question?
Yeah, someone's asking here, if you're building a new application and you maybe decide that you're going to use TypeScript, but you've got some code that you've written in the past just in JavaScript, can you still use that code within your TypeScript application?
Yeah, generally in new applications, for let's say production goals, I would prefer start with using TypeScript. Make more sense for me. After you just start using TypeScript, it's a little bit hard to not use it even in small projects. So for me, make a little bit of sense to start independent of smaller or big projects with TypeScript. So, but you can use JavaScript yet. This is the great magician of the TypeScript that we have. You cannot use it aside and just build parallel things. I guess if you start with TypeScript, it will make more sense. Just continue with growing with this code base. Generally, the gradual adoption you prefer to use in the already existent project. So for new projects, I prefer just start as using TypeScript. I guess maybe makes more sense, and generally the documentation and cheat sheets, like I said, help me a lot on this.
Yeah, someone's asking here if it's possible to use XJS components with TypeScript when you're developing.
I do not have experience specifically with XJS. I know that already supports TypeScript, but I don't know if I have someone more experience on this specific stuff to clarify this for us.
So if Wemmerson, are you online? Can you hear us at all?
Yes, I'm online. So
hey, cool.
Thank you, guys. So EXJS does not ready for TypeScript yet, but you can also, for example, if you would like to use, can you hear me well?
Yeah, we can hear you well, yeah.
Okay. If you would like to use, for example, EXJS components and also use TypeScript, you can use our new tool, React. So you can use both React framework and also take advantage from TypeScript and also use EXJS components. So as a built-in solution, EXJS is not ready yet for TypeScript. All right. Thank you.
Okay, that's awesome. Yeah, it's great. This is one of the great things about JavaScript. There's lots of ways to be able to build and work things together, and I think the React
Yes.
components
In
and
the
actually showing some of the strength and flexibility it brings into development there as well, which is awesome.
If you are
Thanks
curious,
very
so
much.
in the first day, Marcus Mano just introduced the React package, so you can take a look on that on our sencha.com page and check how React works. It's amazing package. Thank you.
Okay, super. We'll get somebody to put the link for that into the chat and send that through. So, okay, let's have a look. I think there's another question that had popped through here. Are there any kind of frameworks you'd recommend for people who are starting development with TypeScript to use with their code base?
We have some frameworks focused specifically built on top of the TypeScript, like Angular, for example. But a great thing of the TypeScript itself is that there's a lot of frameworks and tools and libraries that already uses it. Another is just adopting it, and you can use partially, for example. So we don't have a specifically kind of, in my vision, focused on kind of framework focused on TypeScript itself, because it's just a way to reach your target. So in a lot of the frameworks and libraries existent, you can use JavaScript or TypeScript too aside the code.
Okay, and I think you kind of covered this here. The can a TypeScript object inherit from multiple interfaces?
Sorry, can you repeat?
Can a TypeScript object be created based on multiple instances? So I guess you had the example of a car earlier and a person. So could you create an object that uses the car interface and the person interface? There might be a transformer. There we are.
Yeah. Yeah, basically, yes. TypeScript is really flexible in this part, and you can extend as interfaces and types that you need. Generally, in huge applications, you prefer to split those types and just join it in the most convenient time. So this is one of the goals of the TypeScript flexibility, to provide you ways to split this code and just group it or join it in a way that you have a kind of transformer of data before.
Yeah. Yeah, so okay, I've actually got a question because I mentioned I kind of program in Delphi a lot. We use generics and generic types an awful lot. Does TypeScript have any concept of generics at all?
Sorry, I guess my phone is just
Okay.
charging. I'm not sure. Just to repeat. Yeah, I understand the generic part.
Yeah, does TypeScript support generics?
Yeah. Basically, the JavaScript and the TypeScript itself allows you to reuse things and things like this. And generically, it's a kind of reusability concept. So it's a kind of core part of the TypeScript itself.
Okay.
You can just pass a kind of generic type for a function, or a type that receives a generic. I had created a slide in a file to show it, but it does not fit on the size of the presentation, so I just skipped it. But I can share the slides with all the examples. But in the example code, you have the generics and extensibility examples to cover this part too.
Okay, yeah. Okay, super. Yeah, it's kind of it's great watching you go through doing the introduction to TypeScript. There's so much that makes TypeScript feel familiar to non-JavaScript developers, because you can see clearly the same brain behind Delphi, behind C# is there driving TypeScript. the construction points, the way that it's put together, it's structured, the kind of the feel that you get of everything is really kind of clear. And I think that's one of the great things about the development world. You know, the great ideas that were originally developed and pushed out back in the mid 90s now, with object-oriented programming, interfaces, and so on, are still the same principles that are being tried and tested and are now showing through in web development and bringing kind of all the power of the stuff together. I thought it was really interesting that you showed at the end there, looking at SonarQube. I know certainly static code analysis is something that is on the rise and people are really looking to for the future. We certainly have some customers around the world now who are mandated to make sure specific testing elements are available and shown for the code that they're producing to enable them to develop and deploy applications out to governmental organizations and so on. So it's a really important part of what you kind of look into. And having kind of testing programs, be it SonarQube, be it Sencha test, be it any of the other ones that are out there, it's a really important part of a developer's processing is to actually build those into your workflows, which I think kind of goes back to one of the earlier questions about, does it slow me down? Well, actually, I think sometimes these things actually help speed you up, and certainly as you're looking at the maintenance and the long life of code bases, having your unit tests and everything in there just make a big difference to being able to ensure that you haven't done anything really stupid when you do make updates, because we know what it's like when you're developing something, it's all fresh in your head, everything that's in there, and then you put it aside because you have another project, and then 3 months later you come back to it and you want to make a change. You've then forgotten half the stuff that you've done and why things were linked together, and those unit tests save your life. So definitely make sure you've got your testing regime in place. So.
For sure. And I like to say that TypeScript is a kind of JavaScript dressed to party, because as you said, it's quite familiar for a lot of people that already knows JavaScript, and understanding it like as a development tool that will slow you a little bit on the start and speed up in later, and as you said, in projects that you eventually open up and need to fix something, will help a lot, for sure.
So, Luciano, we are pretty much out of time. So sorry to those who we haven't managed to get around the questions to. But I wanted to thank you again for a fantastic webinar. PrimoDev, you are certainly a #1 developer from the stuff we've had a look at there. So that was a fantastic session. Thank you very much for joining us today.
Thank you for the opportunity.
So let's just wrap up JavaScript Days 2024. A big thank you to all the presenters we've had in with us this year. I can't believe it is day 3 and we're at the end of it already. But a big thank you to Stephen Strake, General Manager of Sencha, for backing the conference really and helping us enable us to get everything running here. A big thank you to Mark, Andres, Raphael for the day 1 presentations, taking us through some great stuff around React with the and how to use the Sencha components in there, looking at how we can use the kind of ChatGPT for coding in a much faster way. There's been some absolutely fantastic sessions that we've gone through, looking at component building. Obviously, we had Wemerson, Daniel, and Nils, Vivan, and Luciano finishing off today. So, been amazing sessions we go through. We would love to kind of get your feedback through, so please go ahead and scan the screen, get your phones out and take a quick link off of the QR code there. Please do provide your feedback through on what you've loved about the sessions and help us drive what we'd like to see in the future as well. And as a reminder, we will have the replays going up on the JSDays.io website, and also they're going to be linked up on the Sencha YouTube channel as well, so youtube.com/Sencha. So with that, my name's Stephen Ball. Thank you very much for joining in. We've had literally hundreds and hundreds of developers each day joining us from around the world. We've had thousands of you registered up for the event this year. I know we've been bombarded already with requests for the replays, hence why I'm just reminding you exactly where they will be posted up. So what we're doing right now is we're going to be taking the recordings of the sessions, just cleaning up the dead spaces and bits, and then getting those posted up and live online. I think the first ones may even be heading up this evening if they're not all there already. So do keep an eye out. They are coming soon. We've had a fantastic time hosting you. You know, these sessions wouldn't be what they are without one, the presenters, but also the great questions and the comments that are fed through to us. So thank you all for listening and joining in and sharing your time with us. We hope to see you back next year. And yeah, please keep an eye out on some of the amazing sessions and other topical events that are being run by Sencha in the coming months. So I'd just like to sign off. Thank you very much. Have a great rest of your day. Happy coding, everyone, and take care. Thanks and goodbye.